Okay, another structure which we'll call as stack. Okay, stack is a basic data structure. It is called an abstract data structure. Stack is an abstract data structure because it doesn't exist. We apply rules on a array and we will make it exist. Okay, actually it doesn't exist, but we'll apply rules on an array and we make that data structure. So that's why it is called an abstract data structure. Okay, so the basic structure of a stack will be, we'll call it as like this. Stack will be like this, as if we are stacking books. Okay, as if we are stacking in books. So in this, there is only one mouth. So through this mouth we'll be putting in the values, and through this mouth itself we'll be taking out the values. Okay, this stack data structure having only one mouth. Okay, through this mouth we'll be putting in the values, and through this mouth itself we will be taking out the values. Okay, putting value to the stack is called push. Putting value into the stack is called push, and taking off the values from the stack is called pop. Okay, so two functions are there for stack. One is push function, second one is pop function. Putting value to the stack is called push, and putting pop, taking off value from the stack is called pop. Okay, so I'll just explain with a concept with if there is a series of steps like push 5, push 6. Okay, instead of first I am writing pop. Okay, first I am writing pop, then I am writing. So we are starting from here. Okay, pop, then push 5, push 6, push 7, pop, 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 push 8. Okay, let this be a series of steps that need to be executed. First step is to pop, then we are pushing 5, pushing 6, pushing 7, pop, then pop, pop, then pushing 8. Okay, so these are the steps that you need to execute. Okay, first you have an empty stack. First you will be having an empty stack. Okay, first you will be having an empty stack. When you try to pop a value, since there are no values inside this stack, the stack will return an empty. Okay, the function will say that the stack is empty, you cannot pop anything because this stack doesn't have any value. Okay, so this will return an error message saying that the stack underflow, we call it as stack underflow, says that the stack is empty and you cannot pop. So it is called stack underflow. Okay, now when you are pushing 5, what happens? First the 5 will be stored. Okay, we'll be inserting it in this way. Now you are pushing 6, so what happens? On the top of it, 6 will be stored. Okay, and when you are pushing 7, what happens? On top of that, 7 will be stored. Clear? Then if you are calling a pop function, what happens? This 7 will be taken out. So here there won't be any 7. The top value will be 6 and 7 will be displayed, or 7 will be given to the program which called that pop function. Again, if you are write pop, what happens? Again, the next value, the topmost value now is 6. The 6 will be getting out, so 6. And there won't be 6 anymore in the stack, so the top value will be 5. Again, if you are writing pop, if you are calling the pop function, the 5 will be getting out, 5 will be getting out, and there won't be any value in the stack. Clear? Next is push 8. So what happens? Since the stack is empty, 8 is pushed to the first position, which is also the top position. Hope it is clear. So this is a push and pop function. Okay. So in this we can know that first the whatever the value that is got out is 7, right? 7 is got out first before 5 and 6. Okay. So the order is 5, 6, and 7. But when you use the stack, you got it in the reverse order. Okay, so that is why it is called last in, first out data structure. Whatever the value you inserted last will be taken out first. Okay, so that is called a stack data structure. I hope it is clear. Okay. Now next one, it is the queue data structure. Okay. Next one, it is the queue data structure. Queue data structure, it is having two modes. One mouth is used to take out the value, and the other mouth is used to take in the values to the data structure. So this is called a stack. This is called a queue. Okay. And the process of putting in the values to the queue is called enqueue. The process of taking out the values from the queue is called dequeue. Okay, the process of taking in the values is called enqueue. The process of taking out the values is called dequeue. Clear? So, right, similar to that, I will just say I am writing dequeue. NQ5, NQ6, NQ7, DQ, again DQ, again DQ, NQ8. Okay, so first the queue is empty. Okay, so this is the outward mouth and this is the inward mouth. Okay, first the queue is empty. So if I call the DQ function, what happens? The queue is empty, so it will give out that queue underflow. Queue underflow. Okay. Next, when you enqueue 5, what happens? The first position 5 will be stored. Then when you enqueue 6, then next position 6 will be stored. In enqueue 7, 7 will be stored because this is the mouth in which the data is entered to the queue. Okay. Then when you dequeue, here the first element that need to come out is 5. So first 5 will get out. Okay. When you again dequeue, there is no 5 here now. So the front element is 6. The front element is 6. So 6 will get out of the loop from the queue. So 6 gets out. Okay. Again, when you dequeue, 7 will come out. Okay. So in whichever order you insert, it will get out in the same order. These elements will get out in the same order as you inserted. That is, if the element is first in, it will get out first. So it is called FIFO data structure. First in, first out. 5 is the first element that is inserted to the queue, and 5 is the first element that got out from the queue. Okay, so this structure is called FIFO data structure. First in, first out data structure. Okay, so that is called queue. I hope it is clear. Okay, and the next one we'll be dealing with is graph. Okay, so next one that we'll be dealing with is graph. So what do you mean by a graph? Actually, a graph is a connection of elements. Okay, connection of elements. So let it be 1, 2, 3, 4, 5. Okay, 4, 5. Okay, so these are connection of nodes. Connection of nodes in any order is called a graph. Graph is of two types. So one is undirected graph and second one is directed graph. Okay, in undirected graph there won't be any arrow marks, but in directed graph there will be arrow marks. Okay, if I am writing the same graph as directed graph, it will be having arrow marks. Okay, and going through these nodes in the graph is called traversing. We call it as traversing. Traversing. Okay, traversing is the process of going through the nodes in the graph. It is called traversing. So in this graph, you can go from 1 to 2, and also you can go from 2 to 1. Okay, the motion from each direction is possible. For directed graph, whichever the direction is given, only the movement from that direction is possible. Okay, so in this graph, you can move from 1 to 2, but you cannot move from 2 to 4 since it do have a direction. Okay, and this is called the edges. These lines are called the edges, and these circles which do have values are called the nodes. Okay, so these are called the edges, and the these circles having the values are called the nodes. Okay, so this is a graph. Now, how to store a graph? You will be storing it is in the form of adjacency matrix. Adjacency matrix. Okay, adjacency matrix. Okay, so here there are 5 nodes. So the adjacency matrix will be having 5 rows and 5 columns. It will be a square matrix. It will be having 5 rows and 5 columns. So here it will be 1, 2, 3, 4, 5, and here it will be 1, 2, 3, 4, 5. Adjacency matrix. It will be having 5 rows and 5 columns. Okay, if there exists an edge between this row, we will mark it as 1. If it doesn't having an edge, we will mark it as 0. Okay, so 1 to 1 there is no edge, so it is 0. 1 to 2 there is an edge. 1 to 3 there is an edge. 1 to 4 there is no edge. 1 to 5 there is no edge. Likewise, you will be filling this. Okay, 1 to 2 you will be having edge. 1 to 2 to 2 no edge. 2 to 3 no edge. 2 to 4 there is an edge. 2 to 5 there is no edge. Okay, likewise 3 to 1 there is an edge. 3 to 2 no edge. 3 to 3 there is edge. 3 to 4 there is an edge, and 3 to 5 there is no edge. Okay, 4 to 1 there is no edge. 4 to 1 there is edge. 4 to 3 there is an edge. 4 to 4 there is no edge. 4 to 5 there is an edge, and 5 will be having an edge only to 4. Okay, so this is the adjacency matrix. Okay, using this matrix, this is how you will be storing a graph. You will be storing a graph using an adjacency matrix. Okay, I hope you understood how to write an adjacency matrix. Clear? Okay, now what you gonna next is there are two types of traversals. Two types of traversal. The first one is DFS. DFS. The second one is BFS. Breadth first steps. The first one is DFS. The second one is BFS. Okay. In DFS, just understand that you will be using in DFS you will be using stack, and in BFS you will be using queue. Okay. In DFS you will be using stack, and in BFS you will be using queue. Okay, I'm not explaining the algorithm much, but understand that DFS will be using stack and BFS will be using queue. Okay, clear. Now, how to traverse this graph using BFS? Okay, so I'll be drawing this graph again. Okay, so I'll be drawing this graph again, and I will just explain how we are storing this. Okay, so let the graph be 1, 2, 3, 4, 5. Okay, let this be the graph. Okay, so let this be the graph. And in the either traversal, even if it is BFS or DFS, you have to understand which is the starting node. Okay, you have to find in the question itself it will be given which is the starting node. Let the starting node be 1. Let 1 be the starting node. Okay, if 1 is the starting node, if it is a BFS, okay, here, okay, I'm just connecting this also so that it is an actual graph, okay, not a tree. Okay, so this for BFS. Okay, so breadth first search. So how we will be starting? The starting node is 1. Okay, so in BFS first we will be displaying 1. 1 is the starting node, so 1 we will be displaying 1. Okay, then which all nodes that are connected with 1, you will be writing which all the nodes are connected with 1. Okay, which all are the nodes that are connected with 1? Which all nodes that are connected with 1 is 2 and 3. So we will be writing 2 and 3. Clear? Now we will be writing which all nodes are connected with the 2. Which all nodes are connected with the 2? 4 is connected with the 2. So next we will be writing 4. Clear? Then you will be checking which all nodes are connected with 3. which all nodes are connected with 3. 1, 4, 5 are the nodes that are connected with 3, but actually 1 and 4 we have already written. So we won't write it again. So which all nodes are connected with 3? 5 is connected with 3. Okay, so this is BFS. I hope it is clear. Okay, so how we wrote BFS? We'll first start with the source node. Now first we'll just check whether which all nodes are connected with 1. Which all nodes are connected with 1? 2 and 3 are connected with 1. So you'll write 2 and 3. Now you will check which all nodes are connected with the 2 and which are not written. Okay, non-traversed neighboring elements of 2. We call it as non-traversed neighboring elements or non-visited neighboring elements. Non-visited neighboring elements of 2. Neighboring elements of 2 is 1 and 4. 1 we have already written, so we will be writing 4. Now we will check to the next one, 3, which is the neighboring element of 3, 1 and 5. 1, 5 and 4. 1 and 4 we have already written, so the next one it is 5. Okay, then we will check with 4. 4 doesn't have any non-visited neighboring elements. Likewise, 5 doesn't have any non-visited neighboring elements. So this is called the BFS. I hope it is clear. Okay, that is breadth first search. Breadth first search. Okay, next one is DFS. Okay, DFS also starts with 1. DFS also starts with 1. Okay, DFS also starts with 1. Okay, so it's actually uses stack. DFS uses a stack. Okay, so what happens is, first of all, I will be using a stack. I will be inserting 1. I will be inserting 1. Okay, then I will be popping the value from here. I will be popping the value, that is popping. So first what you have to do is insert the initial node. Insert the initial node. First what you have to do is you have to insert the initial node. Then pop the node. Pop the node and display it. Okay, you have to pop the node and display it. So what is there in the stack? It is 1. So you will be popping the node and you will be displaying it. So 1 will be displayed. Then what you will do is you will be just pushing the non-visited neighboring elements of 1 to this stack. What are the non-visited neighboring elements of 1? We call it as 2 and 3. Okay, so 2 and 3 are the non-visited neighboring elements of 1. So I will just insert 2 first, then I will insert 3. Here, I can insert it in any order. Any order I can insert. Either it can be 3, 2, or I can write 2, 3. Okay, so 4. Okay, so I have inserted as 2 and 3. Okay, now again I will pop the value. Again I will pop the value. The value popped is 3. And I will display it. Okay, so 3 is popped. Now what you do is you will be pushing the non-visited neighboring elements of 3. Non-visited neighboring elements of 3. Non-visited neighboring elements are actually 4 and 5. So you will be inserting 4, then you will be inserting 5. You will be pushing again the popping the value. The next value is 5. So you will be displaying 5. You will be checking whether there is any non-visited neighboring elements of 5. There are no non-visited neighboring element. Only the neighboring element is 3, and we have already written 3. Okay, so there are no non-visited neighboring elements. Again, you will be popping the next value, that is 4. So you are popping 4. You are popping 4. Okay, popping out 4. And you will check whether is there any non-visited neighboring elements there. Okay, there are no neighboring elements. The neighboring elements are 2 and 3. Already 3 is here and already 2 is in the stack. So there are no non-visited neighboring elements. Okay. Then next one that you will be popping is 2. So the output will be 2. Okay. Any non-visited neighboring elements of 2? The neighboring elements of 2 is 1 and 4. It's already visited, so there will be no non-visited neighboring elements of 2. Okay. So the output will be 1, 3, 5, 4, 2. Okay. This is the breadth first traversal and this is the depth first traversal. BFS and DFS. Okay, clear.